Now, we've talked about this concept of luminosity. Luminosity is the amount, simply the amount of energy, the total amount of energy that's radiated by the star per second. Now, energy per second, that's joules per second, or watts, very important. The units for luminosity are just simply watts. Essentially, luminosity is the same thing as power, the power that the star generates. Now, how much power is coming from a star is going to be ultimately dependent on two things. Number one, the absolute temperature. The hotter the temperature, the more radiation that it emits. And this is a function of what's called Wien's law, and we're going to look at that in just a little bit. Secondly, what's going to determine how much energy leaves the star? The absolute temperature will tell me how much leaves 1 square meter of the star. Now, what I need to know to figure out the total luminosity then is how many square meters do I have for this star. So the luminosity depends ultimately on the absolute temperature and on the surface area of the star. And that's seen in the equation for luminosity, which is simply L is equal to the Stefan-Boltzmann constant times the area times the 4th power of the temperature. So L is luminosity. Again, L will have watts, I should say units of watts. And to find that, what I need is the Stefan-Boltzmann constant, which I'll write that down. Stefan-Boltzmann constant is 5.67, sorry, my mistake. 5.67 times 10 to the minus 8th watts. Now, I need to cancel out the units for these two. The units for this are going to be square meters, so that's watts per square meter. And the units for this are kelvins, but it's kelvins to the 4th, so I need K to the 4th. That's the Stefan-Boltzmann constant. With this information, the surface area of the star and the temperature, I can determine the luminosity of the star. Now, normally, you wouldn't be given the surface area of the star. More than likely, what you would be given is the radius of the star. And so as a result of that, you would need to know an equation for the surface area. And surface area is equal to 4 pi r squared. This is an important equation because oftentimes you may not be given the surface area and you'll have to calculate it. Just to give you an example, the luminosity for the sun is approximately 3.9 times 10 to the 26th, and you are actually being asked to memorize the approximate value of the luminosity of the sun. In that case, you don't need to worry about the 3.9, you just need to know that the order of magnitude is about 10 to the 26 watts. Some stars have luminosities 1,000,000 times greater. Some stars have luminosities 1,000,000 times less than the sun. So you just need to have at least a ballpark figure of what the average value for stars and therefore for our sun at about 10 to the 26 watts.